Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you out with number 37 in your homework. So first of all, the picture I guess is a little misleading. I should have probably redrawn the picture because this young person here is shooting her arrow at 20 degrees from the vertical instead of minus 20. So really the arrow is going this way. I think in the next iteration of this, I'll change that picture, but so that is not the case at all. This is now our 20-degree angle. So our velocity vector looks something like this. And again, it's the same magnitude as it was before. I'm just going to call it v sub o. And just like before, you start all of these projectile problems by breaking the velocity vector into horizontal and vertical components. So you're going to calculate that one. That's going to be some number. Calculate this one. This is the initial velocity y direction. That's going to be some number. And really the only difference between these two problems, like numbers 35 and 36, and this one, is that in the previous two, when the velocity vector pointed down like this, we were getting a negative number for initial velocity y direction. Here, it's going to be a positive number. And what's going to happen is when you draw your graphs, right, velocity in the x direction is it's going to be some positive number, and I don't want to finish the graph for you. Velocity in the y direction. Now before it was down here because again it was some negative number before, and I'm referring to the initial velocity in the y direction. Now it's going to be up here somewhere, some positive number, but still decreasing with time. So you're no doubt going to need the equation for that line, right? Keeping in mind that you can read the intercept right here, and the slope is the acceleration, gravitational acceleration, negative 9.8 meter per second. And I've got other videos on how to derive those equations of motion for this, but I suspect we're going to have to do that somewhere. Give me a moment to scroll down and take a look. Yeah, it said something about when is it going to hit the ground. So the reason I put a dot here is to get equations of motion here. Right? Your change in y is coming from this area. And this distance is a number. And then this distance is a function that you're finding here. And you should end up with an equation over here that'll be quadratic. It should end up with a minus 4.9 t squared if you do it right. And then once you have that done, you can put negative 30 in for your change in y and solve for t. So that should get you rolling on this. Hope that this helps. Have a great day.